ax plus b. What type of graph is this? Linear. It is also called what? Degree 1. And linear graphs are aligned, so they go something like this. Correct? For this linear graph in this form, what can you tell me about a and b? If my equation is in the form y equals ax plus b, what is a? Yeah. Right, why?
Because it ends in the top right and the y-intercept is a positive.
Exactly. So a tells me how I end on the right. It ends up on the right, so a is greater than 0. Then b is my y-intercept. My y-intercept is positive, so b would also be greater than 0. So I don't actually need numbers in order to tell how a and b would be, correct? What is the minimum number of x-intercepts for this graph? 1. It's a straight line. Can it curve? No. So its minimum is 1. We agree? The maximum number of x-intercepts on any polynomial is equal to the degree. So what is the maximum number of x-intercepts for this one? It's 1, because this graph is degree 1. So linear has to cross through at least once because it has arrows, it discos, right? If it discos, it has to cross through at least once. Okay? The maximum number of x-intercepts is equal to the degree, which is 1. Okay? Now I want the domain. What's the domain of this graph? X such that x is an element of the reals. And for all polynomials, that's actually it. Unless it's a word problem. What's my range because this one discos? What's the range? Y such that y is an element of the reals. How many turning points does this graph have? None. It's a line. Turning point is a max or a min. And not an absolute max or min. A turning point is a max or a min. It could be in the middle of it. It doesn't have to be the absolute. Correct? So that's our linear. What about quado? We have y equals, that doesn't look like a y. We're going to try again. Y equals ax squared plus bx plus c. What is this? Quadratic. And what degree is it? And if I gave one in this form, what could you tell me about A and C? Anyone know? A and C? Phil?
A is negative, but C is positive.
Right. A is negative because I'm down on the right. I'm also down on the left because it's a quadratic. Quadratics always end in the same direction. They don't disco, right? Even degree functions don't disco. But we only have one even degree because I can only take you to cubics. Okay? So because it's down on the right, I know my A is less than 0. And C is my y-intercept. Because if I plug zeros in for these x's, it would give me the C, and C is greater than 0. So what's my minimum number of x-intercepts? Minimum.
1.
Minimum. It's actually 0. Why is it 0? Because the entire graph could be negative and be below the x-axis, right? Or the entire graph could be positively the coefficient and be completely above the x-axis, right? Because the arrows aren't discoing. The discoing arrows, because they're in opposite directions, at some point have to cross through, and therefore you get a minimum of 1, right? But degree 2 doesn't have to cross through. I could have a graph like this. I could have a graph like this, right? What's the maximum number of x-intercepts? What's the maximum this graph could have? 2. Because that is the degree. Remember, the max is equal to the degree, and this is a degree 2. Can it also have 1? If you know the minimum and you know the maximum, it can have any variation between that as well. So if the minimum is 0 and the maximum is 2, it can also have 1. And how does that look? Well, 0 would be like this. 1 would be tangent to the x-axis, so it would touch and bounce back up. And then 2 would be just your generic go through. So it could have 0, 1, 2, right? The domain is still x to the element of the reals. The range is the only one that has a complicated range. So if my graph has a maximum, the entire y's are lower than that, correct? So if it happened to have a max, my range would be y such that y is less than or equal to that max, because that's the highest it could be, y-er. If it has a minimum, my range would be y such that y is greater than or equal to the minimum. Please don't write minimum. You have to write what the minimum is. So tomorrow on your test, please don't write minimum. You have to say what the minimum y value is. You have to find it by finding the minimum with your calculator, right? Please don't write the word minimum. I get people doing that. I'm like, no. And then our last graph is in the form, well, we actually have one other one, but it's a unique one. Y equals ax cubed plus bx squared plus cx plus d. Which is what? Cubic. Or degree what?
Degree.
Now the catch with cubics is they could have a point of inflection, or they could have a max and a min. Now people are like, these aren't the absolute max and mins. I didn't ask for absolute max and mins, just ask for a max and min, right? So if our graph has a point of inflection, where it inflects, it doesn't actually max or min out. If it has a point of inflection, that is no turning points. The definition of a turning point is a max or a min, right? So a cubic can have a point of inflection or no turning points, or a cubic can have a max and a min, which results in 2 turning points. What did I forget about on the quadratic? What does it have? A max or a min, so what does a quadratic have? Not turning point, yeah, 1 turning point. And then linear has none. I personally, unless it's a word problem, love linear and cubic because the domain and range are x, er, y here. Like there's really no thought process on them. That makes life so much easier, right? So unless it's a word problem, then it does affect it. So my domain is x such that x is an element of the reals. And my range is y such that y is an element of the reals. Now, you help me out. What's the minimum number of x-intercepts? Yeah, it discos. It has some little weird wonky disco, but the minimum number of x-intercepts is equal to 1 whenever it discos. It's going to have to cross through at some point, correct? What's the maximum number? I don't know why it's not. Yep. It's 3 because it's equal to the degree, right? My board doors won't extend, but I want to show them. So if I go like this, this would be one x-intercept, right? If I wanted 2, it would have to go through and then bounce off tangent. That's 2. And if I want 3, we just do a triangle. Okay. Right? Do we agree? So if the low is 1 and the high is 3, I can also get 2. Remember, you can get every varying level in between. And then our last little one that everyone forgets about is this one. Y equals A. Or an example could be like y equals 6. What kind of equation is this? It's called A. Starts with a C? Nope, starts with a C. Rhymes with constant. It's a constant. What degree is it? 0, because I can go x to the... That's supposed to be a different color. I can go behind it and put an x to the 0, right? Right? So it's degree 0. Now the definition I told you of a polynomial exists if and only if its exponents are whole numbers. So 0, 1, 2, 3, 4. They can't be fractions. They can't be negative, right? So examples of things that are not polynomials. Last thing, and then we're going to go through all the questions. Examples that are not polynomials. So say I have y equals 3 root x plus 6. Guys. So root x is the same as what? We talked about this yesterday. X to the 1/2. So this could be rewritten as y equals 3 x to the half plus 6. Is a half a whole number? No, so that's not a polynomial. Some people get this one. Y equals 3 to the x. My exponent is actually a variable. That's for sure not a whole number, right? So that's not a polynomial. And the third one is, say I give you y equals x squared plus 2 over x cubed plus 1. People tell me, well, that's a polynomial. Because they're all, I have a 2, I have a 3, I have an x to the 0, I'm good. Except this x to the 3 moves up here and it becomes what? Talked about this yesterday. If I bring this up here, what does this exponent become? Negative. So this is actually the same as x squared plus 2x to the negative 3 plus 1, which would be x to the 0. So here's my issue. The one that tricks people that is a polynomial, this is the one that is a polynomial but people don't think it is. So I'm not putting it in the not polynomial column. Is they'll go like this. Y equals root 3 x squared plus 6x plus 7. What are my exponents? 2. 1. What's this one? X to the 0. Are my exponents a problem? No. Is that root over the x? No, it's just over the coefficient. So that is actually a polynomial. This one throws people off. This is a polynomial. Because the square root isn't over variable. Whereas in this one it is. Right? That's just root 3. Root 3 is a decimal. We can have decimals in front of our x's. We do in a lot of our word problems. Okay? Okay, we're going to flip to the front of the booklet. So we are going to, tomorrow there's a whole bunch of highlighters. Tomorrow we're going to highlight as we go through our stuff because it will be helpful. So here it says, a 15-gallon tank is being filled with water. So we have a 15-gallon tank full, that it can be full. It's being filled with water and has a pump that will cause it to drain when the amount of water inside the tank is at a certain volume. The volume of the tank over a 3-hour period, so this is for 3 hours. After 3 hours, we can't follow, we don't know if it follows this actual formula anymore, right? Could be empty for all we know. Then it's not going to keep following it. This is the function. Is this quadratic, cubic, linear? What is this? Quadratic. Y represents the volume of water in the tank in gallons. And T represents time in hours afternoon. So what do? I go here and I say, this is volume in gallons. Right? Volume in gallons. And T is the time afternoon. So that's what I help myself out with. I say, okay, this is T, which is X, to help myself out, right? Which is time afternoon. So let's discuss this. What would we put in for T if we wanted noon? What would we put in for T if we wanted noon? 0, because T represents the time after noon, right? So noon would be the starting point. Noon would be time 0. 1 p.m. would be 1. 2 p.m. would be 2. 3 p.m. would be 3, right? So our time is starting at 0. So here we go. Let's read through this again. It says to determine the volume of water in the tank at noon. Volume of water in the tank at noon. The characteristic that would help us analyze that. Time of the tank in noon. What does T equal? Tank at noon. What does T equal? 0. When T equals 0, that's the same as saying X equals 0. When X equals 0, what are they asking us to find? Every time X equals 0, we're looking for the y-intercept. And when Y equals 0, we're looking for the x-intercept. So when we are looking for T equals 0 or X equals 0, they're indirectly asking us to find the y-intercept, correct? Which is 8. All right. This one says the maximum volume. Do you see this? The maximum volume. So if they're saying maximum, I know I need to find the maximum. And every time I find the maximum, there is an X and there is a Y. X in this case is T. Y in this case is Y because the equation is Y and T's. Right? Y's and T's. So T represents time, Y represents volume. So which of these two are they asking me to find? The Y. They're asking me for max volume. So when I find my maximum, I want whatever the heck is sitting there. Correct? Okay, everyone type the equation in. I know you've done it before. We're doing it again. Because people call me over and they're like, I can't get it to show up. What happens? Everyone can type it in. They cannot get it to show up. You're not useless. It's hard to do the question.
My questions are done.
I know, but we're practicing again. Do you have one of these? Do you have one of those?
I just need batteries. One or two batteries.
Everyone trade my batteries. Someone erase.
Yeah, well,
You can trade my batteries for this class. You gotta put my batteries back.
what if we just switch one battery for one battery?
It works.
It'll work.
Okay, we're recording. No. We're recording. Okay. So, everyone have it typed in? And we're not just basing it off Mrs. Lepp typing it in, because guess what? Mrs. Lepp doesn't type for you tomorrow. I was happy to. You call me over and you're like, Mrs. Lepp, I can't get it to work. Can you type it in and change my window? I'm going to look at you and go, no. Love you, but no. That's what I'm going to do. Love you, but no. And then I'm going to walk away. Because I can't. Because tomorrow's test day. It's T day, not D day, you know? It's test day. All right. So we go to our y equals, and we type in negative 2x squared plus 5x plus 6. Now, what do I know about this equation? At the very minimum, I know that this is concave down because of the negative leading coefficient. And what's my y-intercept? What's my y-intercept? Guys? No. It's 6. So if I go zoom 6, my standard window, I see if it fits, it does. Now, why did I try zoom 6? Because I always try zoom 6 if I'm stuck, right? It's the standard window. But also I know the y-intercept was 6. So it's not like when you see at the back and it's plus 800 and you press zoom 6 and your y-intercept's at 800, do you think it's going to be helpful? No. So let's make some good educated decisions on our window, not just freaking out. So we need to find the maximum. So we do second trace. Every person is doing this with their calculators because Mrs. Lepp is not going to be using their calculators tomorrow. It's your day to shine, not mine. Okay, so the maximum we need on the left-hand side, somewhere on the left. Here, 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 here. As long as I'm on the left, enter. Then right bound, I need to be somewhere on the right. I could stop right there. I could go further. I could do whatever I want. I just need to be on the right somewhere. I hit enter. Yes, hit enter. And I get a maximum at 1.25 and 9.125. Tomorrow you will be asked for one or the other, maybe sometimes both. What does the 1.25 represent in this equation? The time it reaches maximum. The volume reached maximum in the tank, correct? And what did this one max out at? 9.125 before it started draining again. Yeah, it's a 15-gallon tank. Cool, that's awesome. It didn't get there. It didn't get there, and it drained before it got there. So don't tell me 15. Okay? So it's 9.125. That's my highlighter. 9.125. But I need it to the nearest. I go back and I say, Mrs. Lepp's going to... Oh, boy. Nearest tenth of a gallon. So what am I going to put? I go to my 10th spot, which is 1 decimal place. I look here. Is this 5 or higher? So I say no. And then I go 9.1. Right? Okay, next page. Which of the following is most likely a cubic? You're going to help me out. What is this one?
Quadratic.
This one's quadratic. This one is cubic. This one we're going to learn next, after exponentials and logs. This is sinusoidal. It's trig graph. And this one is an exponential, which we're learning on Friday. And why is it exponential? Because it starts off slow and then it grows hecka fast, which is exponential growth. Exponential growth is really fast growth. Exponential decay is really fast decay. Like, for example, if you go to the hospital and they make you take some radioactive material so that they can actually do a test on you, you want it to decay quickly. You don't want to walk around like a Teenage Mutant Ninja Turtle and like have that radioactive material sitting in you for a long period of time, right? So you want it to have a really fast half-life. You want that baby to decay, get a test, and it'd be out of your system. Yeah? Yeah. All right. Okay. Looking here. Which one of the following polynomials has the same end behavior as this? This is a cubic. That means it discos, correct? This is a quadratic. It don't disco. So we don't pick that one. Quadratics have arms up or arms down, right? Yay, arms up. That's all they have. So we have to deal with the other three. If this one is a cubic and it's positive, it ends up on the right and then down on the left. We agree? Because it discos. This is up on right, so down on left. What is this one? Linear. What does this mean? Down on right, up on left. We agree? What about this one? Up on right, down on left. It discos, doesn't it? So this is the one that matches. Why doesn't this one match? Down on right, up on left. Okay? All right. Flipping over. Let's talk about this one. Let's see what it means. Everyone's paying attention, right? Because we have rationals and polynomials on our test tomorrow. So we can do well on this. We're practicing. A hockey arena, 1,600 people. That's max, right? No matter what, at maximum, this arena can fit 1,600 people. Does that mean it's actually going to hold 1,600 people? No. It means at maximum, if I sat someone in every single seat, 1,600 people, perfect. Cool. So it says the cost of a ticket is $10, right? So currently the cost of the ticket is $10. Now it says at this price, every ticket is sold. To obtain more revenue, The arena management plans to increase the ticket price. So they're going to increase it. And then if they increase the price, they might lose a few people from coming. Correct? So if they increase the price, they may lose a few people, but they might make more money still, because the increase in price and a little less people could actually make us a bigger revenue. Right? So currently their max revenue is $16,000. Do you see that? At 10 people times 1,600 people, it's 16,000. Yeah? Okay. So here it says a survey was conducted to estimate the potential revenue per ticket price. So here, if I had changed it to $15, I would make $1,950 and have a little less people. If I changed it to $20, I would make $20,300. $25, it's now too much. I'm now actually making less money currently, right? I went past what is going to be the best ticket price. I actually raised it too much, and now way less people are coming, and now I'm not even making that $16,000. And then if I raise it to $30, they're like, no one's coming. Like, no, thank you. That is too much. Okay? So what happened is I started at a price, I went up to a highest price, and I came back down. Is that linear? I went up, and I came back down. Is that linear?
No.
Linear is a straight line. That would mean as I was increasing the price, I would just still keep making money. Okay? So this isn't linear. So it says this model is a quadratic regression. Does that make sense? I went up and I came back down? Yeah? Quadratic regression, it tells you that. It also just shows you the equation. But it tells us here that x is the ticket price, so I know that this is my x. Remember how you're like, I don't know for sure which one's x and which one's y. They tell you, too. So if they made them out of order, you should at least catch that they were out of order. I've never seen them out of order, but if they did, you should be able to tell, because they just said x is ticket price in dollars. And then y is the potential revenue in dollars. So then this is my y. Correct? Everyone's typing it in. We're practicing. I don't care that you did it already. Do it again. And then it wants the ticket price that would maximize the revenue. Ticket price, maximize revenue. I see maximize. I know I have to find the maximum. Do they want the x or the y with ticket price? So I go up here and I say, which one's ticket price, x or y? So do you see I always label my tables? Label my tables. I rhyme. I label my table. I label it. Ticket price is x. So this time, they want this from the maximum. Right? They want the ticket price. They want the x of the maximum. So everyone's typing it into their calculators. I am too. If it lets me. Make sure you clear out your y equals. Every single time you start a new question, you should clear out your y equals, right? Okay. Shh. Make sure you're working. I'm still recording. Change your window too. Okay, shh. Make sure your window's fitting the data. Yeah. So we need to change our data, our windows to fit our data. The window should not be hard because we have lows and highs in our actual window, right? So I saw that the lowest was 0 and the highest ticket price would be 30. I could have went to 40 or to 50. And the potential revenue, you can make no money, or at the max it was 20,300, but that doesn't mean that's actually the maximum. That's just the maximum on the table. So I went to 25,000. So I go second, trace maximum, which is 4. On the left, enter. On the right, enter, enter, and I get, it wants it to the nearest whole number. And I need, this is the ticket price, This is max revenue. Which one did it ask you for? The maximum ticket price or the maximum revenue? Ticket price. So it's going to be 17 because I have 17.1. Oh, I keep forgetting that. 17.1. And if I look to this number, this is the one I'm rounding to. This is not 5 or higher, so it's just going to be 17. All right. Going to a new question. What do we immediately do? Go to our y equals and clear it out. Because there will be some of you who will literally use the same equation for like 4 questions and it's going to go bad. And you won't even know to be sad. Okay. So I go to my graphing calculator, I go to my y equals, I clear it out. Okay. So here we have a pump is used to drain an 80-gallon tank. So this time we now have an 80-gallon tank, and we're draining it. When the volume of the liquid within the tank reaches a maximum safe volume, the volume of liquid in the tank V, so this here is volume, and volume is Y. I always put my little variables beside it to help myself out. Because in your calculator you have X's and Y's, not B's and T's, right? So I always say what this represents. And it's volume in gallons. So the volume of liquid in the tank V over a 10-hour period can be modeled by this function, where T represents the time in hours. Afternoon. Oh, once again, X equals T equals time in hours after noon. So noon again is 0. Okay, to the nearest tenth of an hour. This is important. Nearest tenth of an hour. What happens if you round wrong? How many marks do you get? 0. There's no one going, oh, bless them. They rounded wrong. Bless Timmy and Sue. I'm going to give them, no, there's no one. There's no one who loves you. Like, I love you, but the diploma doesn't love you. Like I meant, okay, let's backtrack. When you hand in, there's lots of people who love you. I love you. Everyone loves you. We love you. Okay, cool. But you hand in, I feel like I should kumbaya you, because that made that sound really bad. I love you all. I really do. So when you hand in your sheet, bubble sheet in the diploma, okay, it has your little sticker on it without your name on it. It's just a sticker. It's just a number. They don't even know to love you because they don't know who you are. It is just a number sheet with like a little sticker on it with a, they scan it, and then that's it. And then this sheet goes like this. Beep, that's it. The sheet is just shook right through. And then it's marked. So that's what I mean when I say there's no love for you. Because they don't even know it's you. And it's a computer. Like there's no tie to this. There's no little grandma up there marking it for you, being like, oh, this look, I'm sure this person really tried hard and just rounded wrong. Like, I know it's 20.1, but they put 20. I'm sure they're cute. I love them. And then it gives you check. There's no one who does that because it is a computer with a sheet that just goes shook. And your name is not attached to it, okay, for anyone to see to love you, okay? I love you here. And you will round wrong, and I will probably make a check mark. You've seen it before. You've probably already done it. And I check it off, and I say, on the diploma, you will get no marks. You are lucky I love you. That's literally what I write, okay? But on the diploma, there's no one to love you because they don't know you, and it's a computer, okay? Have I clarified when I said what I said, which was totally incorrect? But I love you, and I will still give it to you. But the diploma will not. So we need to at least listen to our rounding rules. What? Sure. It's not true, Alex. It's not true. Okay. So, to the nearest tenth of an hour, the first time the volume in the tank reaches 55 gallons. Oh, I keep forgetting which side's my highlighter. Okay, so did they give me Y or did they give me X? Did they give me Y or did they give me X? They gave me the volume. So they gave me Y, and when they give me Y, it goes into my Y2. First time, try it out, let's go. Typing it in. So you go to your calculator, and you type in 30x minus 3x squared, right? And then in our Y2, we put 55. Okay? Now let's think about that. Our y2 is a horizontal line at 55. So if I go zoom 6, and you're like, the line doesn't show up. It's maxing out at 10, okay? My y2 is 55. I have a horizontal line at 55, but my screen maxes out at 10. So somewhere up there on my board, like above it in like all that horrible like hole spot, because it took my projector out, up there is a line at 55. Okay, can I see it? No, it's on my board, way up there. It's imaginary, correct? So I need to make my window, if I'm putting it to y2, if I'm putting in 55, my y max has to be at least 55 or I can't see it. So I'm going to put my y max at 60. That is an x, Crystal. That is an x. Grab a mitt. Okay, my y max needs to be 60. And I press graph. Ha! I see it. Okay? So if your y2 is a number, your y max needs to be bigger than that, or it can't see that horizontal line. Okay? We want the first time. So we go second trace 5. And I need to get near the first time. Enter, enter, enter. What happens if you give me the second time? It means you didn't read, which a lot of you don't do. Like a lot of you are like, I got this. I've done this a lot. I'm going to bypass all the words but gallons and 55. And I'm just going to give her what I feel. My heart is feeling. Don't do that. Okay, so it wants to the nearest tenth of an hour. So I go 2, oh, I keep forgetting that. 2.41, blah, 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 blah. I don't care about the rest because I want nearest tenth. So I go here. I look at the 4. And then I look here. Is that 5 or higher? No. So it's 2.4. Okay? Next one. I have a new question. What shall I do? You can answer my question before you go.
Oh, you gotta clear your question.
Yeah, clear your y equals, yeah. So go to your y equals and clear it out. I'm not even going to read the question until I clear my calculator. Did everyone clear their y equals? So until we clear our y equals, we don't even read the next question. Now I cleared it, I can talk to it. A stone is thrown vertically upwards. Oh boy, that's not working like this. A stone is thrown vertically upwards. Okay, we have gravity. So at the very least, we know what's going to happen with this stone. I believe in you. It's going to come back down. It's not going to be a linear equation because we have gravity. So a stone is thrown vertically upward. The height of the stone above the ground was recorded at half-second intervals for the first 3 seconds. Here's the data in the table. So this is my x, this is my y, time, height. Using the quadratic regression, I want the maximum height. So I know I have to find a maximum, and I know maximum is going to give me 2 values, and then I know x is what because of the table. X is what? The time. So this would be the max time. Time to reach max, right? And this is max what? Max height. So which of the 2 numbers do I want? This one, right? So everyone go figure it out. Go, go, go. So, stat, edit, clear, enter. Shh, clear, enter. So this one we have 0, 0.5, 1, 1.5, 2, 2.5, and 3. Shh. Then we have 0.5, 10.3, 17.6, 22.5, 24.9, 24.9, 22.4. Stat, calc, quadratic, 5. Y equals, bars, statistics, over to equation. Okay, every time we get ourselves an equation, guys, we have to make sure we change our window to fit it. Correct? So, this window is 0 to 3, so I'm going to say 0 to 5. And then it has 0, and it's at 24.9, so I'm going to maybe pick 30. And press graph and hope I can see it. Boom, there it is. So it wants the max height. Height is y, so second trace maximum If it says maximum or minimum, we have to find that and then pick which one we need. So the max height is 25.2, which is B. Then it says to the nearest tenth of a second the time for the stone to hit the ground. You have a stone doing this. I want when it hits the ground. What is this? It's the x-intercept. So I go second, trace. Come on. Second, trace, trace, second. Number 2. I don't know, it just needed to be revamped. And then left bound, enter. On the right side of it, enter, enter. And I get 4.511, blah, blah, blah. And it wants it to the nearest tenth of a second. So what is it? Oh my gosh.
4.5.
I'm struggling. 4.5. Next page. We're going into turbo mode. All right. This one's a linear regression, and it says X is the price of the home, and Y is the number, and it can be formed by a linear. X is the price of the home. Y is the number of homes. Guys, it always has to tell you which is X and Y by the equation. So if you call me over and you're like, which one's X and Y, but the equation tells you which is X and Y, I'm just going to look at you and be like, oh, you're cute. Just read it. Just read it. Try it out, you know, a little highlighter. Might hand you a highlighter. Maybe that's what I'll do. That's what I decided. If you're not reading, I'm going to hand you a highlighter. That's going to be my hint. Like, read. Okay. So using a linear regression, the data above the value of B. So we go to Y equals, we go to stat, we go to Y equals, clear it. We go to stat, we go to edit. We put in some big numbers. And we get 375,000. 400,000. So we go stat, calc, linear, which is 4. Guys, if you're picking anything other than 4, 5, or 6 tomorrow, are you wrong? Yeah, because there are no other ones currently. We'll add more, but right now that's the only ones we have options for. So if you're like, I really like 7, I'm going to use it. Okay, you're going to get it wrong, but you know, you do you. All right, so B is 620 to the nearest whole number. Oh my gosh, I'm not adapting. 620. And then using the above model, the number of homes sold from 700,000. So that is, now, watch this. So 700,000 is my X. So I go to second, trace, value, because this is going to happen to you guys tomorrow. And you're going to go, oops, I didn't even put anything on Y equals. So vars, statistics, over to equation, enter. Now, are you guys watching? Because when you call me over to help you tomorrow in this situation, I'm going to say, remember this moment. So you guys go second, trace, value, and you go 700,000. And then it errors you. And you're like, what's that? There's an error. And then I'm going to say, remember, at 1:16 p.m. yesterday, when I said there's an error with you when you put in an X, the problem is that your window ain't big enough. Okay? I want to find 700,000. My window X max is 5. Probably not going to work. You know what I'm saying? So I'm going to go, I'm a rebel. So I'm going to go 700,002. Yeah, rebellious. That's what I am. So now I'm going to try again. Second, trace, value. True fact, you don't actually even have to see it. You just need to have the X value on it, because it'll work even this way. 66.5. Can I get 0.4 of a house somewhere? No, so I actually write 66. Oh my gosh, adapt. 66. We have to round down because you can't find point something of a house. Okay, degree 3. Which of the following is not possible for degree 3? Which one's not possible? We just went over this at the beginning. Degree 3 can look like this, which is a no turning point or a point of inflection, correct? So those two are out. Degree 3, which is a cubic function, can have a point of inflection, which we talked about, and no turning points. Or a degree 3 can look like this, which is how many turning points, people? So that one's out. So what's the only thing it can't have? One turning point, because that's quadratics. Yep. The end behavioral graph of a polynomial is such that the left tail is down in quadrant 3 and the right tail is down in quadrant 4. In our graph, so the only way that can happen is if it's a what? A degree 2 or a quadratic, right? This is a constant, it goes straight like this. Linear has to go like this or like this. Cubic has to go like this or like this. The only way I can get arrows in the same direction is degree 2. Graph of 4 cubic functions are shown above. So we need one that's negative leading coefficient and a y-intercept of 9. So it needs to be down on the right, y-intercept of 9. Oh wow, that looks like 4. This one is down on the right with a y-intercept of negative 8. Oh, that looks like 3. This one is up on the right, up on the right. What's the difference? My y-intercepts. This one is a y-intercept of 5. So this one's 1. This one is a y-intercept of negative 7. So it's 2. So it's 4, 1, 3, 2. Which of the following rows has same end behavior? This one's quadratic and cubic. It's not even possible. This one is up, up. This one's up on the right, down on the left. This one is up, up, positive. This one is down, down. This one is up on the right, down on the left. This is down on the left, up, or down on the right, up on the left. This one is up on the right, down on the left. This one is up on the right, down on the left. This one here, and these, oh, I want to go to this one. All right, let's talk about graphs. So, if I want to draw this graph, everyone please type it in your calculator. I need to talk to you about drawing graphs, because some of your graphs are terrible. Yeah. So type that into your calculator. So I have negative, in my y equals, negative x plus 1, x minus 2 squared. All right. You guys scare me. So you guys, if I ask you to sketch a graph or draw a graph, first off, that's a highlighter. If I ask you to sketch a graph or draw a graph, guys, this is what I literally get. Perfect. Cool. And then you guys do this. Okay, so it's about like that. It's about like that. It's about like that. It's about like that. Oh, oops, I bumped. Wow, silly me. Okay, sorry. It's like this. And then it's like this and like that. This is what I get. Not a coordinate to be found. You just, yeah, it's about that. Okay. I'm just going to sketch it right off here. I'm going to willy-nilly it. It looks like it's approximately this. Ah, yeah, cool. It's perfect. No. Bad. Don't. What? No, you have to stay. I saw yours. You stay. All the rest of you stay. I don't even know why I let those two go. No one in this class drew a nice graph. Not one. On the polynomial 100. No, not one of you. I think every single one of you willy-nilly did. I don't think anyone found a point. I think it was just like freehand. Not time. I'll hand the polynomial 1 into you. No, sketch means draw. Okay. So we're going to find some coordinates. We're going to try it out. Okay? Let's find the x-intercepts first using our calculator. So second, trace 2. I'm going to find the first x-intercept. Enter Enter, enter. Oh my goodness, it's at -1. Guys, I'm not joking. Paying attention, because this is gonna, like, I was joking, but I'm not really. It was sad. Made me almost tear up. Okay. So -1 is here. I plot that one. I plot the other x-intercept. It's at 2. Then I need some minimums, some max. Whoa, it has them. Let's, okay. Second trace min. Then I go left bound. And then I go right bound. And this one has a minimum. What is it? If it says e to the -6, what's that the same as? Just a 0, right? E to the negative anything is 0. It means 10 to the -6, but it would be 0.0000001, blah, 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 which we can round to 0, right? That's what e to the -6 means. So if you see that, it's 0. So this one's at 0 and -4. Shh. Guys. Okay. This is not enough points for you guys, because you guys will willy-nilly it from here, and you're like, Mrs. Lepp, I've given you all the points you need. I got everything. You have an expensive calculator that will give you tons of information. Like, let's use it. So, if I go second trace value, let's try it out. Second trace value, an x pops up, correct? I can put in any x value, and it will poof out a y for me. Tons of coordinates, right? So I want one on the opposite side. Maybe I put in -2. Second trace value -2, and I get 16. Then you're like, Ms. Lepp, that's too big. Cool. Do I have to pick -2? Could I pick -1.5? Yeah. Second trace value, -1.5. That's 6.125. Cool. I can use that. So -1.5, 1, 2, 3, 4, 5, 6. It's here. Right? I have another coordinate. Crazy. Now I can go second trace value. I can go -0.5. And that's no. That's -3.125. Stop it. So second trace value is the way to go. So I go -0.5 and -3.125. So I'm like here. Do you see I'm getting more coordinates? Then I do second trace value 1. 1 and -2. And I can go second trace value 2.5. 2.5 and -0.87. So it's like here. No, it's like here. Then second trace value -3. Oh, that's -50. That grew real fast.
When we run out of time if we did this last report?
There's one graph.
Okay.
Will you graph in every single one?
No,
Oh my goodness. So, if I give you one graph, do you think that that's unachievable for me to expect you to find coordinates and actually plot more of them?
No.
No. My heart says no. My head says no, which means no, it's not. You guys should be able to do it. If you guys willy-nilly it off of your calculator, I promise you, you are getting no marks. Like not even 1, not 0.5, not like a generous anything. If you just go, yeah, yep, cool, put my little thingies in here, yeah, cool, and then I'm going to go here, yeah, perfect, completely accurate. Life is golden. No, it's not. Life is bad. Life is sad. I'm not happy. Okay, do you guys understand what I'm saying? They don't look the same. My minimum's over here on this side. To your eye, they look the same. To a trained mathematician, they do not look right. They are sad. They are terrible. That one I didn't finish control. On your polynomial thing, that's what you did. Yeah.
We can't just kind of.
Wait,